Now I'd like to do something similar with our scatter plot data. Okay, so I have a bunch of data. It may or may not be, in this case it looks very independent in that there doesn't appear to be any trend anywhere. What happens with the analysis of variance, the difference is, again, what we have is that the response variable in analysis of variance is categorical. The explanatory variable, so like our x, would be numerical, but the response is categorical. And so, in essence, when you're using an ANOVA, it's kind of like what you've done is for any given x value, you want to know something like low, medium, and high. And so what we would do is, if we had our low, medium, and high for our response, or y variable, then, here, well, if I just started numbering them, there's x1, x2, x3, x4, and so forth. X1, x2, x3, x4, and so forth. Here's maybe x28, x29, that kind of thing. X42, x43, down to something. So, what we've done is we've categorized the response variable, but we did not categorize the explanatory variable. And so, in this case, if I were to look at the averages of the x values for each of these, what I'd find is the average value for the low looks like it would be really close. So, XL would be really close. It's about the same as XM, and it's about the same as XH. If we call those the average value, that's H. If we call those the average values in each of these categories. Right, and so they would all look about the same. We would expect that our analysis of variance wouldn't have a small p-value, it'd probably have a big p-value. But on the other hand, if I had, say, a downward trend in my x's, when I categorize that same way, low, medium, high, well, notice here, my x high bar would be somewhere in here. There are all the values for the medium, so its middle is somewhere in here. And here are all the low values. Its medium, its middle, or average, is somewhere in here, and you see they look very different. X bar H looks to be much smaller than XM, which is much smaller than XL. Okay, and so probably if we ran an analysis of variance on something like that, then we would find that we probably do have a small p-value. And so again, with numerical in each, for both the explanatory and response, it's pretty easy to go toward the ANOVA this way, where we would set up the low, medium, high categories, and we would fill in our data, our x values for each one of those, by just looking at the x values here, the x values there, and the x values there. We would fill that in. So it's pretty easy to see that way. Not so easy to go back the other way if you do not have ordinal categories. So, if this was blue green and yellow or something like that, well, how, which one would I put where? I don't know, but what you would still see, even in the case like that, if these really were different, right, you might say, well, we'll just, for the heck of it, we'll go, blue, green, yellow, and if we do that, then, well, you might do your X values, but you do them all in a line like that, and then your X values all in a line like that, X values all in a line like that. So you might see something like that. But, which one of these is supposed to be bigger? Who knows? I just went with what I had here. We could have mixed it up into, could have done blue first, then yellow, then green, in which case green would have been somewhere in the middle there, yellow would have been down there, and blue here if we mimic kind of the high, medium, low stuff. Okay, so, but as I look at those, they, even from a scatter plot point of view, it definitely looks like something is going on there. Okay, and so that's the relationship between the types of data we would have in an analysis of variance, and then for our chapter 6 when we do our regression. And in our case in particular, we're doing linear regression. Okay, so that is that relationship. Again, if you definitely have a downward trend in your data or an upward trend in your data, if you were to categorize it, you should probably still see similar p-values. Similar as in if regression shows that things are dependent, probably ANOVA will as well, and vice versa. And I guess that's about it for this one. So that is our relationship between chapter 6. So this is our chapter 6. Oh, sorry, no, chapter 5. Yeah, chapter 5. And this was our chapter 4. Okay, but see, we're basically doing the same thing. It's just what kind of data do we have? How are we going to actually get a test for it? And so if we have all numerical data, chances are we'll probably use some sort of a regression. Okay, so we'll call that good.